Hello and welcome to this Codenomicon Fuzzing 101 webinar. My name is Ami Chuso and I will be hosting the webinar today. Our speaker today is Mr. Ari Takanen, the CTO of Codenomicon. He will be talking about zero-day vulnerability management. If you have any questions, please feel free to send them to me through the chat window. All the questions relating to the presentation will be answered at the end of the webinar in the questions and answers part. All questions relating to technical issues will be answered directly. This webinar will last approximately 1 hour plus questions and answers. So, without further ado, I will give the floor to you, Ari.
Thank you, and hello everyone. So in this presentation I will be going through zero-day vulnerability management from fuzzing perspective, but also looking at different aspects related to that. But before going to the actual topic, I'll just give a short overview of myself for those of you who haven't joined any of my presentations before. So my background is in academic research at University of Oulu in Protos research group, where basically we have been developing fuzzing technologies since 1998. And later, around 2001, we spun out from the university and founded a company called Codenomicon, where basically we continued the development of the techniques in commercial aspect. And I've been also, basically my work consists of evangelizing topics around security, ranging everywhere from IPTV to mobile technologies, wireless, and so on. But really, the key focus of my research has always been around fuzzing, which I will be explaining also during the presentation. So the agenda for today is looking at zero-day vulnerability management and what it actually means. Many of you are probably familiar with traditional vulnerability management and the shortcomings and weaknesses in that, but let's look at how vulnerability management can actually approach the difficult topic of 0 days also today. After the introduction, I will look at the different phases in my demonstrations, first in the theory and then actually in practice, if we are lucky and none of the demos fail, like we actually had problems in the earlier presentation this morning. So we will go through looking at network analyzers, which are tools for mapping threat surface and attack interfaces in networks. And then we will look at zero-day detection with fuzzing and fuzzing-related technologies. And then we will look at how to actually fix and remediate different zero-day weaknesses, vulnerabilities, using systems such as intrusion detection systems and intrusion prevention systems. And after that, we'll briefly look at how also patch verification can be approached with a combination of known vulnerability data and fuzzing and traffic generators such as fuzzers. So in the end, hopefully we can squeeze in all these in practical demonstrations as well. But let's get started so that we can go through all these topics. As Ami said, we only have like an hour for the presentation and demo, so my apologies if this goes through quite fast in rapid fashion. So let's get started. Looking at zero-day vulnerability management, the basic principle in zero-day aspect of the vulnerability management process is moving from reactive security to more proactive approaches in the vulnerability management process. So that means that instead of reacting to someone else's security discoveries, reacting those usually in quite late phases. With proactive approaches, you can stay ahead of the industry and security know-how and actually proactively protect yourself from the zero-day weaknesses. So before going into that, it's good to understand what a zero-day means. So looking at vulnerability lifecycle, or what other people call it like window of vulnerability, many people, especially in traditional security, they speak about window of vulnerability starting from the discovery of a security weakness. So when a weakness is found in software and disclosed either in limited fashion or publicly, that's often where people think that the vulnerability lifecycle starts. But in reality, the vulnerability lifecycle and the window of vulnerability starts when the programmer makes that mistake and the software is actually released. So immediately when software is released, it already comes out with a predefined set of weaknesses, vulnerabilities. And when security researchers, security companies, hackers, when they find these problems and expose those, that enables software developers to actually release updates and patches for those. But the other weaknesses are still waiting there as 0 days, waiting to be exploited by hackers or by just random incidents in the network. So when we look at traditional vulnerability management, the greatest challenges are that it is focused on detecting vulnerabilities after they have actually been found by someone else and after they have been disclosed to security companies and to public or to the vendors. So they are not looking at the vulnerabilities as they emerge in software because those weaknesses are already there hiding. They are only reacting to the security discoveries after the fact, after someone finds the weakness and actually publishes it. And quite often, when you look at the tools in vulnerability management, especially like IDS systems with default rules and settings, they are often protecting from systems that you might have already patched. So many of the rules and systems that they are looking, trying to detect those attacks, they're actually looking at weaknesses that have already been fixed in your own network. And if you look at traditional vulnerability management, most of the costs are actually in patch deployment. So not only from vendor side, but also from enterprise side and from every user perspective as well. So it's always like a crisis management process. First, when a hacker or security researcher reports the problem to the vendor, they often have to get patches out in very short time frames. And also when they actually release those updates, they have to be deployed in very short time frames. So it's always like running after the next vulnerability and next weakness, trying to fix it before it's been hacked by the malicious people out there. And when vendors do fixes quickly and when patches are installed quickly, that process is quite prone to errors. You cannot test every single configuration. You cannot make sure that none of the patches break some other things in the network. And also, every time you need to reboot your services or servers or software, those maintenance downtimes can be quite expensive actually. And especially if you get new patches several times a week and you don't have time to test each patching process, then you are quite prone to also make some mistakes. So just reactively reacting on weaknesses stays as a constant race against the adversaries in the internet.